Welcome back, everyone. Announcements first. Number one, today I am going to talk about your next assignment, assignment 6, and it's going to be due in a week. So you have a new assignment. You're going to have one after the lecture, and you have 1 week to work. It's an individual assignment. So you are going to work alone. Your responsibility to do your work and submit your own work. So individual assignment, 1 week. It's all about architectural patterns. Obviously, it's involved programming. You're going to submit source code in Java and a class diagram. You can finish in a couple of hours. What I am going to do today is to give you a draft of the class diagram and some ideas of the source code that you need. So basically, what you need is to complete what is on the slides, what I am going to describe to you. You can do that in 1 day, a couple of hours, depending on your background programming, but you have a full week. The reason for the week, as usual, you can work today, during the night, finish the assignment, submit, or tomorrow, or during the weekend, or if you prefer, in a week, use hours before submission, up to you, but you can finish in 1 day, promise. Any question that you could have during the week, you can send an email to me, to the TAs. Please ask any question before submit. Do not wait after the due date. Do not wait to submit appeals because something was not clear or whatever. So ask questions, finish your assignment. Assignment number 6. My expectation is to have another assignment next week. So hopefully we can complete 7 assignments in total. Moreover, another quiz. So we could have at least 6, 7 quizzes, at least 1 more coming next week. And with that, you're going to have 6, 7 assignments, 6, 7 quizzes, and that are going to be 25, 25 of your final grade. Also, you already have the grades of your midterm. You know, the midterm is 25% of your grade. And the final exam, some people ask me about the date for the final exam. We already talked about it. When we talk about the midterm, we talk about the final also. Final exam is going to be April 21, our last lecture. I am going to use that day to do your final. Your final exam is going to be used like the midterm. You're going to use the same software, the same environment, the exam on Canvas, multiple choice questions, open questions. For the final, you can expect more open questions. There are more things that we have done programming. So you can expect a number of questions involving, open questions. You need to write things, and those things are source code for a diagram or for a description, apply patterns. The final is comprehensive, so any question that you already answered in a quiz or in the previous exam could be there again. My advice, you can start reviewing your quizzes, your midterm. Be sure that you can answer correctly any of the questions there, so they could be again in your exam. And as you know, 25% your final, 25% the midterm, 25 quizzes, 25 assignments. So you can get an idea about what is right now your final grade and how many points do you need to achieve the final grade that you expect you need. So think about it, review things. Any question, let us know. Yeah, I mentioned that the final exam could have midterm exam questions. Remember, the pools of questions are randomly, the system select question for you. So for some of you, could be 1 or 2 that you already answered. For others, maybe all the questions are going to be new. It's random. You should have access to all the quizzes, the questions and your answers, and the correct answer, well, they are in the lectures, in the slides. You should be able to answer any question in quizzes or in the midterm with the information that we have reviewed during the lecture. So check the questions, check your answers, review the videos, review the slides. Any doubt, let us know. Yep. Okay, so final exam, the 21. We are almost done with the class, 2 more weeks, 2 topics that we need to cover. but that is the plan. Good. So your next assignment, that is what I want to talk today. Previously, we review architectural patterns. I review with you the class diagram and the source code, and hopefully you have the opportunity during the week to review that source code, diagrams, maybe work a little bit with the topics that I asked you to review, threads, sockets, and so on. Let's see. Model view controller, you are expert with this. You know the source code for this, the class diagram for this. Blackboard. We review this idea of the Blackboard with threads. I share with you the source code. It's in a different set of slides in another lecture, but you remember this picture, the Blackboard. This idea of a central place for the data, shared memory space, and this idea of student-professor, or sources of knowledge and the control. Several entities can put data in the Blackboard, and there is this one entity, the professor, that somehow control what is happening there. Usually control means delete or replace data, somehow organize what is happening. So the Blackboard pattern. We talk also about the client server. I share with you source code for the socket. For assignment 6, for the assignment that I'm going to introduce today, we are only going to use this one, the Blackboard, and this one, the model view controller. So assignment 6 is architectural patterns, model view controller, and Blackboard. I am not going to include the socket, not for this one. Hopefully we have the opportunity to use this in the next assignment. Let's see what happened. So Blackboard with model view controller, that is your assignment. And I need to talk about the specification. What is going to do the assignment? Number one, I am asking you to use the model view controller pattern. Therefore, my first requirement, I am asking you to submit for the first time packages. I am asking you to submit your program in Java, and that program is going to include 3 packages, 3 folders. I am asking you to use as the names for the folders, view, controller, and model. Let me be clear. It's a very bad idea to use these names. The names should be something related with the project, the product that you are building. However, I need to make the life of the grader easier. And in order to make the life of the grader easier, I am asking you to use these names. It's going to be easier for the grader to grade your work if you follow these names. So I am asking you to submit a project in Java. I am asking you for the packages, and I am asking you to use these template names, model, view, and controller, so the grader could know what to grade. Where did you put the things? So number one, 3 folders. Now, you are going to have in your project, and I am going to explain the details, a repository for information, a place in which some part of the program is going to put data and a different part of the program is going to use that data. I am asking you to use the Blackboard pattern for that. Your repository for the data is going to be a Blackboard, and you're going to have connected with the Blackboard this idea of control. Control is what we call, in my analogy, the professor, and you're going to have this source knowledge, what I call in my example, the student. Blackboard, control, and knowledge source. For your exam, please be aware that control and controller are not the same. Control is the name, the official name, for what we call it the professor in this analogy of the Blackboard pattern. Controller is the model view controller. That controller is your listeners. Remember the events. Control, the professor. Just remember this for the exam. In the exam, you're going to have questions related with this. Do not mix the topics. The assignment is individual. Yes, it's going to be individual. No group. Okay. Good. So yeah, individual assignment. So what is going to happen, and this is the first thing for your project, and hopefully you agree with me, the big picture of your project is going to be the model view controller pattern. Why? Your project is going to have a graphical user interface, that part of the view. You're going to use listeners, obviously, that is going to be part of the controller, and the model, that is the functionality. Well, the model is the place in which you have everything related with the data. And what I am asking you is to use the Blackboard pattern to organize the data. Someone insert and someone have the control, delete or do something extra. Step number one, you are going to use the Blackboard pattern inside of the model of the system. So your project is looking like this. This is not a class diagram. I am using rectangles, colors to share with you an idea. You have a project. Your project have 3 folders: controller, view, and model. Your folders are my gray rectangles, 3 folders. What I am showing you inside of one of those folders, this control, Blackboard, and knowledge source, is used to share with you that all the classes related with the Blackboard pattern are going to be inside of the folder that correspond to the model in the MVC pattern. Makes sense? 3 folders, only 3 folders, not 6. 3 folders: the graphical user interface, the listeners, and all the functionality. The Blackboard pattern is part of the functionality. The Blackboard pattern is handling the data inside of the model. Hopefully this part is clear. Questions? No? Great. Okay. So picture number 1. Now, what I am going to ask you to do in your assignment is 3 steps. I am going to describe the details of step 1 and step 2 and give you the specification for the 3. Step 1. What I want as a graphical user interface for your project is something that is going to look like this. Hard to notice, but what I have here is a frame. The frame that have this close, maximize, minimize, a window. Inside of that window, what I have is a panel. Use one panel. A frame with one panel inside. That's it. Hopefully at this moment, after all the assignment that you have done, how to do this is very, very clear. You are asking me to have a panel inside of a frame. As usual, the requirement is going to be you should use Java Swing. Nothing else, only Java Swing, which basically means that I am asking you here to use frame and panel. Somehow using frame and panel, create this interface. At this point, hopefully it is clear that what you need to do in order to have this result is something similar to this. Number 1, I am asking you to create a class that is going to have your main method. That class is going to be part of the view. That class is the one that is going to create the frame. And therefore, that class is going to inherit from JFrame. What I am giving you in the yellow boxes is mandatory. I am asking you to create the source code for this class diagram, this one. So if this one is inheritance, we are going to grade that you have a class, main, extend, JFrame, just like that. Mandatory check boxes. That is what the graders are going to check. So a class main, extend JFrame, and the main method is there, and also a constructor. At this point, hopefully it is clear what you should have in the constructor. What is the source code that should be inside of the constructor, and what is the source code that should be inside of the main? Things that we're going to review. You have done several assignments like this. We have talked about the source code. I am going to give you a hint, but we're going to review you have these classes and you put inside of the method what we have reviewed should be there. Nothing extra. No, remember, kiss and dry. Do not repeat, keep it simple. So the main for the frame. Second, I am asking you to have a class canvas. I am asking you to use this name, literally, again, to facilitate the life of the grader. And this class canvas is going to be our panel. That means I am asking you to use inheritance. Inheritance from JPanel in the class canvas. And well, because it's going to be a panel, a very important thing that we're going to have here is this method paint component. I am asking you to override the method paint component. As you know, as you remember, as you did before, inside of that method paint component, you're going to be able to draw things on the panel. And therefore, those things that you draw are going to appear on the screen. One requirement for your assignment is going to be to draw things. This is the place in which the drawing should happen. So paint component is going to be there. Later, I am going to transform this canvas to observer. So you notice the update method there. I am going to talk about that in another slide. So update, because it's going to be an observer. Paint component, the important method, because something is going to be drawn there, specifically there. Important, I am asking you to use listeners. In particular, I am going to ask you to use mouse listeners. Something is going to happen in the project. I am going to give you the details that is related with actions in the mouse. In particular, click with the mouse. When you click on the screen, something is going to happen. You know that in order to implement that, you need listeners, mouse listeners. And according with Model View Controller, the listeners, the controller, and the graphical user interface should be separated, should be two different classes. I am asking you to create a class, reporter. Yes, that name, please. And that class is going to be the one that implement the mouse listener interface. You can notice the arrow, inheritance, in particular, realization, implement. That class is the one that is going to implement the mouse listener. Therefore, this class is going to have all these methods, the methods that correspond to the mouse listener interface. We're going to use one of them, this one only, but you need to implement all of them. So the others can be empty. It is fine, just because you need it. If you prefer to use the mouse adapter, the class, up to you. The only difference for the interface, you need to implement all the methods. For the adapter, with one, the one that you need is fine. Any option could work, don't worry. Just remember to update the diagram. If you use adapter, the relationship there is going to be with a solid line because it's a class. If you use the listener, the dash line because it's an interface. Anyway, your homework. Step number one, if you understand this diagram transforms to source code. And remember, each line here have an equivalent as a source code. So the first thing that we're going to grade is that you understand the diagram, that you can transform this to source code. Hopefully, easy. Now, important things. If I show you this source code here, obviously correspond to this class diagram. If I show you this, create an object canvas from the class canvas, create an object reporter from the class reporter, set layout, add the canvas to the center, add a mouse listener, and notice that here we are using reporter, not this. Question, where you should put these lines? Hopefully the lines are clear. Hopefully you know what each of these lines is doing because you have used these lines before with different names maybe, but you're familiar with these lines. Where they should be, yeah, in the constructor, probably this one. Could you agree with me that something that you can do is these lines to the constructor? Step number one. I am not giving you the lines that you need in the main because I am pretty sure that you know what to do in the main. And basically it's to create an object from the class. Done. Create an object that is going to call the constructor. In the constructor, you put this. Done. Second, in the controller, I am asking you to use the mouse listener. One of the methods here, the mouse click, we're going to do something with the user click on the screen. For that method, if I give you this content for the mouse click method, do we understand what is happening inside? Do we understand these 3 lines? Can you guess what is happening there? What is going to be printed or not? I have one yes, and hopefully that one represents the opinion of everyone. Okay, even in Spanish. Thank you. Gracias. So yes, as you put in the chat, these 2 lines open the parameter, the event inside have information about where the user make the click. That where is this X and Y. You have the values, and the only thing that I am doing is to print those values, print the values on the screen. The only reason because I am printing the values on the screen is for you to know that this is working. I am going to ask you to do something with those values. But so far, step number 1, if you can create the source code for these classes, and probably these lines can be useful for you, you can create a program that is basically something like this. You run your program, you're going to have an empty window, use the frame, you are not going to notice that the panel is inside, it's just going to look like this, empty. But every single time that you click on the screen, what is going to happen is that that click is going to print in the console something like this. So this output, these 5 lines, is because I may click 5 times in different parts of this graphical user interface. So every time that I do a click, automatically in the console, I am going to have a line like this with the coordinate X and Y in which I make the click. Notice that all this text, the comma and the equals, is because I put that here. So that is the format. The only important information, the only important thing, the valuable thing is these variables. And those variables are the numbers in those columns. That is the step number 1, that you create this. So that basically you have the graphical user interface, the listener, and that you are able to get the information about where the user is clicking. Done. Step number 1. Clear? Okay. Step number 2. If you have that, the next step is I would like to have not this empty interface in which I make a click and I receive the information about the coordinates on the console. That is good, but I would like to have something like this. I would like to have a graphical user interface in which I make the click, but when I release, in the position in which I make the click, I would like to have a circle. In particular, in this example, a circle in a blue color. So I make the click and a circle appears in that position. If I make another click, another circle appears there, another click, another circle, and so on. Every time that I make a click, there is a circle in blue, kind of a dot, draw in that coordinates, in that point. This one is the console. So I take a screenshot of the graphical user interface and I put the console in the same slide, but it's a good question. That one is the console, the thing with the background in black is the console. That is something that you are going to notice in the console of your IDE when you run the program, or if you run the program in your terminal or whatever, that is what you're going to have. It's not part of the graphical user interface. Good. Okay. So what do we need to do if we want these blue circles to be drawn in the same position in which the user makes the click? At this point, you are familiar with the drawing, and you know that this is not going to happen automatically. This is not something like, okay, I make the click and the circle appear. It's something that you need to program. It's something that you need to have in your source code, this functionality, right? What do we need to do? Two things. Number one, you need to store the information. Right now, what we have from the step one is inside of this method, we have this variable with the values of the position X and Y in which the user makes the click. Somehow, from step one, we have information here in that method. We need to store all these values, those X and Y, in some place. Store the information, step number one. In order to store the information, what I am asking you to do is, well, easy. We review how to store information. We review patterns to handle information. And something that we can do is to take the information from this method and put the information in a data structure that is located in a shared memory space, our Blackboard. Somehow, we need to put all these coordinates, X and Y, all the things that I am showing you in the console, but we need to store those numbers inside of the Blackboard. Every time that the user make a click in the panel notify the listener have the information, and the listener should put the information in the Blackboard. That is what I am asking you to do. Now, the information is in the Blackboard. Tell me where, one place, we can draw the blue circles. There is only one place here in which we can draw the blue circles. Where? In which class? In which folder? In which method? Do we know? Hopefully you agree with me. In which folder? In the view. The blue circles are part of the graphical user interface. In particular, we can draw those blue circles in a panel. Yeah. And in particular, in this class that we call the canvas. And more specifically, the only place, the only method in which we can draw something is paint component, because we have access to the graphics, something that you already did before in another assignment. So this method, most click, is going to put somehow information inside of the Blackboard. We need to discuss the structure of the Blackboard. Right now, it's just a box in blue. That should become a class diagram and then source code. But the information is going to go from that most click to the Blackboard. And somehow, from the Blackboard, should go to this paint component, because paint component is the one that should draw these circles in the coordinates X and Y that are stored in the Blackboard. And hopefully the flow makes sense. The question here is, what do we do to implement this connection? And what do we do to implement this connection? Two connections in the pictures with colors and use lines looks like pretty simple. Our goal, as we have been working, is we need to do those connections in a standard way, patterns, a good class diagram, and then that could be transformed to source code. Connections. What do you think about this? Number one, what I need to do is to create the element. What I need to do is to move the Blackboard to classes. Could you agree with me that the Blackboard is going to be one class? The class that represents the Blackboard. There are going to be another class for the control, and there is going to be another class for the knowledge source. I am going to talk about them in the next slide. But first, the class that represents the Blackboard. I'm going to use this one class, call it repository. And there are two important things that I want you to notice in the class diagram that I am sharing with you. Two important features that I add to the class repository. Can you identify them? Two important things there. Number one, and I think it's pretty simple. I am making repository, my Blackboard. I am making that one observable. Do you remember that I mentioned before that this panel, the canvas, was an observer? The panel is an observer. I create my class repository observable, and these two classes are this connection. Observer and observable. Done. Connection number one, my first question. The connection between the view and the model. Observer pattern. Done. Professor, there is a connection between these two classes? Yes. Do you remember the class diagram for the pattern? Do we put that connection in our class diagram? There is no need. Remember, we don't care about the connection between two classes that are from the library. This observer and this observable are part of the Java API. We show the connection of the classes that we're creating. What happened in the library, we can keep that encapsulated. And our diagram is going to be more clear. For every developer reading this, it is clear that there is a connection between an observer and an observable. They can be checking one to the other. The information is going to flow between those two. And that solved my first problem. The panel is going to have access to the information in the Blackboard because it's going to be observing. It's going to be notified every single time that a new value is in the Blackboard. Done. Second, as you mentioned in the chat, yeah, my repository, my Blackboard is a singleton. Makes sense. Remember the analogy. We are in a classroom. In this case, we call that the main. And in this classroom, we're going to have students and professors, and we have this Blackboard, shared memory. And it's going to be a singleton. There is only one Blackboard in the full classroom. We can have more. There are classrooms that have more. For this example, it's only one, so I make it a singleton. When I make it a singleton, I guarantee that there is only one, but moreover, the access to that single space is going to be very, very simple. I am sure that you remember the name of the class, get instance in any place, and I have access. So that is an advantage that we're going to use here. It's going to be a singleton. Reason, because you know that it's a singleton, hopefully, right now. Number one is because this loop, the reflective loop, the entity, remember, an static entity inside of the class that is from the same class. And I am sure that you notice the private constructor. So the constructor for repository is private. That is a hint that you are using a singleton. So a singleton and an observable. Now, This one is going to be my Blackboard, my repository for the data. And what I am asking you to store there is coordinates X and Y to facilitate things. What about storing the X and the Y in one object? And you know that you have these objects, points. Up to you. There is a class point in the Java API. You can use that one, or you can create your own class point, whatever you prefer. But hopefully it's clear that the object point is going to have two variables, the X and the Y integers, used to put together the X and the Y that correspond to one click. Now, there is not going to be only one. There is going to be several, and several in my class diagram, an asterisk in that relationship. Notice that it's the first time that I am asking you for global variables. In the view, in the controller, there are no global variables. There are no attributes in the classes that I am asking you to use. For the first time, here is a diamond. And that diamond is asking you for attributes, global variables. Global variables, in this case, in the repository for having a data structure that is able to store points. What could be a good option in the source code to create this part of the class diagram? The diamond, the points, and obviously consider the asterisk. If I ask you in the exam to give me the source code to implement the thing that is inside of the red line, what is the source code? Could you agree that what you need is a dynamic data structure? Could you agree, hopefully, that every single time that you have an asterisk in a relationship, when you have this idea of 0 or more, what you need is a data structure that is dynamic? I am talking about a linked list, a stack, a queue, a tree, something that can be growing because of the asterisk. If you have a number, 5, 6, 7, you can have an array. But the asterisk is telling you we need a data structure, whatever data structure you want. Moreover, it's a data structure, and because of the diamond, should be an attribute, should be global. There are going to be several methods using that data structure. Pretty normal. You're going to have methods to add data, get data, maybe remove data. So a global variable, an attribute for storing points. Up to you if you use collection, templates, your own implementation of linked list, whatever. But what you need connected to the repository is somehow an implementation of a data structure, a dynamic one. Done. What can we do to put in this data structure the data that come from the controller, the listeners? What are you going to do to insert data in the data structure? Because so far, looks like the data structure is going to be inside of a class, repository, that is in a folder, model. And what we need to do, what we want to do is to insert information there from another class, reporter, that is in another package, controller. Can we have access to that structure? And if so, how? You mentioned that it's a singleton, right? So hopefully you're going to agree that inside of this method, you're going to have a line of code that is going to be something similar to Something like that. Can you agree, and hopefully this is clear after the things that we review in previous weeks, that the only thing that you need to do inside of the method, mouse click it, is to put that line, repository.getInstance, the name of the class, dot, the name of the static method, and that is going to give you access to the repository for the data. And then the only thing is to call the method. I didn't put here any particular method, up to you. It's going to be a setter, it's going to be an add, and that method is the one that is going to implement the connection between the controller and the repository. Insert the data. Insert the data is there. And hopefully you agree with me that this method here, something that this method is going to have inside of the structure is the instruction notify observers. I am not giving you the full source code, but hopefully you're following me and remember what I am talking about. Are you telling me that inside of reporter, in the method mount click, we're going to call repository.getInstance. For instance, add, and we're going to send as a parameter the value for X and Y, and then we're going to have a method add inside of the class repository, and that method add in the class repository is going to receive as a parameters 2 integers with the coordinates. Somehow inside of that method, you're going to have the source code that is going to put those values inside of an object point, and it's going to put that object point in your linked list. And at the end of that method, you are going to do this set change and notify observers. Remember, it's part of the observer pattern. And when you do that, what is going to happen is this notify observers is going to be calling the method update in Canvas. Just like that. The method update in Canvas can call the paint component, and the paint component can draw a circle in every single space in which we have a point object stored in the blackboard. That is the implementation that I am asking you to do. Hopefully my description and the diagram makes sense. To be more specific, the source code, I am asking you to use this source code. Number one, you remember the update method. You need to override the update method in Canvas because you make Canvas an observer. Remember something here? Canvas is an observer. When you do that, mandatory to provide this method. What happens when we call repaint inside of the update method? What do the repaint instruction? Are we familiar with the repaint instruction? Easy. Repaint, what is going to happen? This one is a call to the paint component. You cannot call paint component directly. If you want to call paint components, what you do is to call repaint. That is how the API works. Repaint, paint component. Think about it. The update is called every single time that a new data is introduced to the blackboard. The only thing that update is going to do is to call paint component every single time that we know there is a new data on the blackboard. And every single time that we call paint component, this is going to happen. Do we understand these lines that are inside of the paint component method? Well, that I am asking you to put inside of the paint component method. blue color. I am asking you to make the circles blue. What is happening here? Do we understand that line? Repository, get instance, get points. It is clear that we are using the singleton. It is clear that we are accessing the repository, the Blackboard, with this repository get instance. Moreover, that once we have the instance, what we are doing is to call one of the methods, get points. And looks like that method is going to return not one, but several points. Several. How many? Several. As many points as the user have created. Oh, those are in a dynamic data structure. My method is going to return the dynamic data structure. Well, you know, it's going to return a pointer to the first element, but the representation for that is something fancy like this. I mentioned before a linked list. Why I am using here a stack? Well, remember, a stack, a queue, they are particular implementations of linked list. I am going to talk about the requirements for you, and later it's going to be more clear why I am moving or suggesting you to use stacks. But the implementation is up to you. It's a dynamic data structure, a list, a queue, a stack, like in this example, is used get all the data from the Blackboard, get all the points. After I get all the points, a loop for every single point. And what I am doing here, hopefully you get the idea. I get all the points. For each point, I open the object, and I get the X and the Y. When I have the X and the Y, just like before, I use those values to draw an oval in X and Y. And well, the size of the oval, 10 points, and I am making this -5 to put the oval exactly at the center where the user makes the click. This is the source code that you need to draw the ovals. You make the click, the listener have the data, the listener send the data to the repository, the panel read the data from the repository and draw the circles. It's a loop. The view, the controller, the model, back to the view. Done. I am sure that you notice this and this. I do not put here a name. What I use in my examples is add. Up to you, the name for that method. Add, set, whatever. You need this one. You need this one. And also, you are going to need in the main this one. Remember the add observer? You need to connect the singleton with the panel. You need to tell, you know what? This panel is observing the repository that is the Blackboard. This is the connection. This line, you need the line in the main. This line, the add, you need the line in the controller, in particular, the mouse clicked method. And you need this line in the paint component method inside of the class canvas. 3 times in which you need to use your repository, your Blackboard. And in doing this, and with all this description that I give you, you are going to have version 2, step 2 done. A program that is going to open this. Still, the numbers are going to be in the console, just for you to check that your program is working. But the important thing is now, in the graphical user interface, every single time that I make a click in some place, when I make the click, I release and I am going to have a blue circle in that position, and I can do that several different times, and it doesn't matter how many times I make a click. For every time, there is going to be a blue circle in the position in which I click. If I minimize the window and I maximize, the dots are going to be there. If I make the window bigger, smaller, it doesn't matter. The points are going to be there because I have the information stored. And every single time that I repaint, the data create new circles. So you never lost the points, the blue circles. Step number 2, done. Any questions so far? Okay, perfect, clear. So step number 1 and step number 2, I am giving you some ideas with the class diagram. I am asking you, mandatory, follow the class diagram. Also, I am giving you some ideas of the source code that you need to use, the name of the classes, the name of the methods, and snapshots of lines of code that could be useful for you. More or less, if you have the source code for the patterns, singleton, observer, and if you have the basic source code of any other application with graphics, like the Pac-Man video game, every single time that I show you in step 1 and 2, you should be able to finish to have this working in a couple of hours. One day maybe. You're going to have 1 week, not because you need 1 week to finish this. 1 week before, because it's up to you to work today and finish, tomorrow, during the weekend, or 1 hour before the due date. You can finish in a couple of hours. It's something easy. Step 1 and step 2, you should have this working very, very easily because you have done things like this before. Maybe with a team, now is your opportunity to do it by yourselves. So maybe in the past, your team helped you. Now you do not have the team, your opportunity to develop your programming skills if you haven't done that yet. So 1 and 2, done, easy. The important part, step 3. Step 3, you're going to start with this. This is the mandatory class diagram. This is the mandatory source code that I am asking you for this part. You should have these classes, these things. And after you have this, the next step, requirements. And for the requirements, I am not going to give you classes or connections. What I want you to do is to modify this and add here in the source code and in the diagram, the things that are needed. The things that are needed for 2 things. Number 1, just imagine that I have this blackboard with all the information that I described before, points. And I want your help to implement the control, the professor, and the knowledge source, the students. Just think about the scenario like this. You already have the blackboard. In the blackboard, we're going to have points, several of them. Each point have this X and Y, X and Y, X and Y. And you have this professor and you have this student. What they are going to do. Number 1, let's start with the students. The students. The user make a click. When the user make a click, I am going to have a new blue dot in some place. First dot, nothing happened. Second dot, I am going to make a click and I am going to create another dot. The dot is going to appear. This is already implemented in step 2. Here, the student is going to do the following. It's going to connect the second dot with another dot. I only have 2 here. It's going to connect these 2. the student is going to draw that line. It's going to create a line connecting the two dots. Okay, what happens if I draw another dot? The student should connect this new one with another one, only with one. The student is going to connect the new dot with the closest dot, with the dot that is close to this one. So the student needs to review and calculate the distance from the new one to the others and select the one that has the shortest distance. So in this example, probably it's going to be this one. And if I draw a dot here, the student should connect these two. And if I draw a dot maybe here, the student should draw a line here and here, or a dot here, or, and I can continue. The responsibility of the student is going to be to create lines. A line between the new dot and the closest one. So every single time that the user make a click, create a dot. And something, the system, in particular, this idea of a student inside of the system is drawing lines between the new dots and the dot that is closest to that new one. Something that I want you to notice. This is the student. I am asking you, the student, to draw the line. Hopefully it is clear that the student cannot draw the line. The line or whatever is going to be drawn here in this method. That method have access, because of the observer observable, to the repository. What the student can do is to put a line in the repository. And do you remember that we create this data structure for the points? What if we create a data structure for lines? The lines that this guy is going to create. Remember, the knowledge of source can read the repository, can write in the repository. The student should be aware of the dots, the new one and the others, should have access to this data structure. And using the data structure, need to calculate a new line. That is the work that I want you to implement here. Do you have an idea how to calculate this? Is this familiar for you? And hopefully, if you have background in computer science, if you take a class about algorithms, this is an algorithm that you know, the shortest path between 2 points, right? The algorithm is easy, is a method, maybe 2. That method or methods are going to be inside of one class. The class student or the class knowledge of source of knowledge. What are you going to do to connect that class with the diagram that I give you? What is the connection of that class with the rest of the project? That is the important part. I know that you can solve this, but the focus is the design, the connection. Please do not make this class the class that is searching for the solution, the class that is calculating the distances. Do not make that class to draw the line. Do not put graphic, user interface, and functionality inside of one class. That is the most common error. And with that, you destroy all the work that we have done with patterns. The new class should do the calculation using data coming from the repository, And the result of those calculations should go to the repository. The panel, the paint component method, is the only place in your full program in which you can draw something, either the circles, the dots, or now the lines. Clear? Questions? Nothing? Everything is clear? Okay. Okay, clear. I will trust you. So next, this is about the students. The students draw the lines. What about the professor? Do you remember we have a professor in the Blackboard? What I am asking you to do in the implementation of the professor is the following. The professor is only one, and the professor is going to be observing what is happening in the repository. And when you have one point that is connected with other 5, one point that have 5 connections, the responsibility of the professor is going to be to delete that dot. So I have my dots, the lines. If one of the dots is connected with other 5, we delete that one. And obviously all the lines that are connected with that dot. And then we recalculate. Recalculate, yes, we need to reconnect the dots. Imagine this example. In this example, well, looks like all the dots here are connected. 1, 2, 3 is the biggest one, this one here. What could happen if I put another dot here? It's going to be connected there. So that one have 4 connections. And what could happen if I put another dot here? And then I have another connection there. So there is one dot, this one, that have 5 connections. Real time, when I detect the professor in your system, detect that one, the green dot having 5 connections, what is going to happen is that that one is going to be deleted. So this point is going to disappear, just like that. And also the lines that were connected with that one. So this line is going to disappear. This line is going to disappear. This line also, this line here, this line, and this line. So your picture looks like this. 5 connections, delete the dot, delete the lines. Next, recalculate. Recalculate, yeah, all these dots that are not connected should be connected. We need to find new connections. New connections, well, looks like we need to apply the same principle. We need to connect the dots with the closest point. Looks like maybe this is close here, maybe this one is close here, this one could be close here, probably this is the closest to that one, and maybe this one is the closest to that one. New connections. All the dots are connected to the closest one, even though I delete the one that before had 5 connections. This is the work of the professor. Student, draw one line for every single new node. Only one line when we add one. This one is always reviewing. Review for 5 lines. Delete and reconnect. I am not giving you a class diagram here. I just give you responsibilities for the control, responsibilities for the knowledge of source that correspond to the professor and the student. You have the class diagram from a previous lecture. Can you include that class diagram? Can you solve this and connect to this one? That is your assignment. What you are going to have now is those functionalities, the professor doing this, the student doing that in a common repository, now with dots and lines. And just to be clear, the lines could be objects that basically have 2 coordinate X and 2 coordinate Y, right? The initial and final point for the line. That could be an idea. You can have the values, or you can have references, pointers, to elements in the other linked list. Up to you, references, pointers, or duplicate the values. We are not really going to review the performance of your algorithm, the handling of the memory. I am pretty sure that you have background on this, depending on your previous courses, but pointers, values, if you have an idea of the best solution, go ahead for that one. Don't worry if you do not have background. Whatever solution that you figure out, loops, variables, duplicate information, that is not going to be part of your evaluation. Your evaluation is more about the design, the connections, the Blackboard pattern. Lines and dots in the Blackboard, professor and student working with that. You complete that, and you're going to have an application like this. The only thing that I am going to do as a user is click, 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 click. Dots are going to appear, lines are going to appear, and in some point, dots are going to be deleted, lines are going to be deleted, and I can continue working forever, just playing with this. That's it. That is your assignment 6. In terms of the software and the functionality, this is the software, this is the functionality. 40% of your grade, complete the software, make it work. The rest, 40%, the diagram. The diagram, as I mentioned before, the thing that I am showing you here in yellow, mandatory that you have it, mandatory that you have those classes with those names. In order to complete your solution, there are things that you need to do here. There are things that you need to do here. And for sure, there are things that you need to do here, probably with the view, in order to draw the lines, because what I showed you was to draw the dots. So 3 things that you need to modify, and that implies source code, but also imply things in the diagram. 40, 40, and I am asking you for a document. In a document, I am asking you to explain your approach to the solution. I am asking you for 1 or 2 pages in which you describe how did you solve the problem, how do you apply the patterns. It's just a small short paper with a description of what did you do and why, and that is going to be the rest 20. So big picture of your grade, just for you to know that diagram and source code are equally important, and the 3 things that we are going to ask you to submit: a document, a diagram, the source code. That's it. Any question, guys? Anyone? Okay, so I am going to stop here, review the video, review the slides. Any question, let us know. See you next week. Thank you.